So this ratio that I just formed for you over here is actually a really important ratio, and it's actually called the tangent function, right? And what the tangent function is or the tangent ratio is, if we look at an angle that's a part of a right triangle. So in this case, we looked at this angle down here was A, right? And when it was at 30 degrees, then, and I'll try to get it back to 30 degrees here in a moment, then for this particular triangle right here, this opposite side, which was, let's see, that side right there, the side that was directly opposite A over here, measured 5.54 units. And these are just units. They're not inches, centimeters, meters, or anything. They're just units, okay? And the side that was next to it, B1, right? So this side we call the adjacent side. It's right next, see it says segment B1 right there, segment B1, okay? That is right next to A, and adjacent means next to, right? So this adjacent side was 9.59 units, and the opposite side, right, was 5.54 units. And then where did we get 1.73 from? Well, when we simplify that by dividing. We just said, what was the opposite side divided by the adjacent side? And I think I've got that formula backwards, because A1 was the opposite. So let's fix that. What we want this to be, we want it to be equal to the opposite side, that was A1, divided by the adjacent side. Okay? So, I've screwed it up because I put that period sign in there, and there we go. So that's the actual ratio that we're looking for. And I'm going to try and just scroll it down a ways, and I should have done this before correctly, but there we go. All right, so we have a ratio that's 0.58. Let me write some things out here. I'm going to come back in to this side. I'm going to put some things in here to write out that are very important. So what we have is we have a tangent ratio, also called the tangent function, okay? So the tangent ratio is equal to the measure of the opposite side divided by the measure of the adjacent side. Now what we're doing here is we're purposefully ignoring the hypotenuse. We're not paying attention to the hypotenuse. Hypotenuse isn't changing right now. We're just talking about those two sides in particular. Okay? So that's what we have here. I'm going to pause this video. I'm going to try to get this back to exactly 30 degrees so that we can explore a little bit more. Okay, so again, I've resized it so that we are looking at this exact angle right here in line 2, where this angle right here measures 30 degrees, okay, and then this adjacent side here, that segment B1, measures 9.59, and we can see that it's measuring that right over here, 9.59, and then this side over here, on that side A1, should be measuring 5.54. So again, segment A1, if we look over here, that's 5.54. All right, so we're dealing with this exact triangle right here. And what we're noticing is there's a ratio of 0.58. So what does that mean? Okay, let's look at ratios again a little bit. Let's kind of go back up where we've got what we'd written before. The tangent ratio is just the measure of one side opposite the other. Well, for a similar triangle to exist, if it was going to be similar, then that means the ratios are going to be preserved. The ratios, the measures of those angles are going to be preserved, right? So let's think about that. What would be the ratio? Well, this is 0.58. So what is that ratio? 0.58 is equal to 58 over 100. 58 over 100. So let's think, and let's put that together. Here we go. Ready? We're going to make a triangle. I'm going to need to zoom way out here and change the scale. I'm going to zoom way out, and we're going to have to move some of these things so we can still see it. We're looking at 58 over 100. So, and the reason I'm changing is because we're going to actually create two sides that measure 58 over 100, and we're going to connect them. So here we go. We're going to make a segment with a fixed length, and this length is going to be 58 units long. And now we're going to make another segment with a fixed length that is 100 units long. And we're going to adjust them, okay? So here goes the 100 unit one, right? And what I want is I want these to be perpendicular to each other, because I know that in this case, this triangle has a length here that is the equivalent, that these two legs come together at the right angle, right? So I'm going to measure this angle here. Let's measure that. And, am I going to measure this correctly? I got the outside angle. I keep doing that. I'm going to have to remember that order somehow. If we want to measure the inside angle, go the other direction. So I'm going to have to try adjusting this, and I hope I can adjust it to get it exactly to 90 degrees. There it was. All right, I've got a right angle with this ratio, right? 58 is the measure of this length. 100 is the measure of this length. Okay? And now what we're going to do is we're going to measure, or we're going to make this right. We're going to make this into a right triangle. Here we go. Boom, 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 and back to MN. Now, what we're going to find out is that this triangle is completely, it's rotated a little bit, and that's okay, but it is completely similar to that original triangle there, and that other triangle too. And here's what we're going to find. Since we know the ratio of 58 to 100 is accurate because we made that ratio, what do you think the measure of this little angle down here is going to be? Well, I'm going to guess that it's going to be 30 because it's similar. So here we go. Let's measure that angle. Hope I measure the inside angle correct. Can I remember how to do that? There it is. And it's just off. Now, why would it be off? Well, it turns out it's off because this number's right here, that 0.58, is a rounded number. It's not an exact number. So, if I could get that properties, and maybe I could actually get it to go out. I want this value here, and maybe I can adjust it so that I can see more. No, I don't know. I'm not going to worry about it right now. But basically, that ratio right there, okay, is really not 0.58. It might be 0.57913 something, okay? It's 0.58 is not exactly right. Now, it turns out that all of these ratios are actually written down in your calculator. So let's see if we can look inside of our calculator and find out what that ratio exactly really was. If I turn my calculator on, I can use what's called my trig functions. That's where those ratios are stored. So I would let me go back to my calculator. Use this button here for trig where it says trig. And I'm going to go down there, I'm going to press trig. And I want to know what is the tangent of a 30-degree angle. And of course it gives me an irrational number with a radical square root of 3 that cannot be written as a fraction of integers top and bottom. That's an irrational number. When I hit Control Enter, it gives me an approximate number. So 0.57735. So if I change these dimensions here on our right triangle to 0.5 to where this would have to be. Now think about to make this right, and even then we might not be exactly right because this might be rounded as well. But 57,735 units on one leg, and the other leg being 100,000 units. That's how big we'd have to make this to make it hopefully hit exactly the same exact triangle. And anything else is just rounding, and it might be just slightly off. But when we talk about tangent now, you know what we're talking about is the ratio of the opposite side in a right triangle to the adjacent side of a right triangle of a 30-degree angle. And it gives me that ratio, right? I can round that out to 577 units over 1,000. And maybe I make that, let's try doing that because we can, no, I'm going to scale forever. That'd take forever. I'm not going to do that. But the rounded from 577.43 is 58 over 100. And it got us pretty darn close. Pretty darn close. Close enough that you should be able to get the point here that we're trying to make. This function, this tangent function, tells us what that side is over what this side is from the given angle. In this case, it was a 30-degree angle we're talking about. Okay? There's two other functions that you ought to know. So let's write them out. And again, we're talking about from that same 30-degree angle, and that is, the first one is called the sine function. On the calculator it says sin, but it means sine. And that would be the ratio of the opposite side over the hypotenuse, or divided by the hypotenuse. Okay? And then you have the cosine, which is written often as COS in your calculator, which is equal to the adjacent side over the hypotenuse. So these are your three basic functions, or basic trig functions or trig ratios, okay? And all they are is they just tell you that you have something here that is adjacent. So we'll take a look here in a bit to kind of help you see how you can use some of those trig functions to help you solve a right triangle. And then you're going to do some practicing of that here in a moment. But that's the important thing to know what they are. And, you know, on your calculator, you can put it in. We could say, what is the, let me hit the trig button again, what is the sine of a 30-degree angle? And it tells me it's equal to 1/2. Which tells me that if I had, oh, that's actually a really good one to use. Let's try zooming in here. That's really good. That turns out to be a very, very nice number, 1/2. All right, that's a rational number, and it's an exact number. So if I had now remember, let's talk about sine. Sine of 30 is opposite, which is this opposite side, over the hypotenuse. The hypotenuse is this one. So let's say that I had that's going to be a nice one to make. Here we go. We had a segment here, and the segment was 1 unit in length. Okay? And then we had another segment here, and that segment was 2 units in length. Okay? And then what we're going to do is we're going to rotate this guy, oops. We're going to rotate this point Q around. So we're going to build our triangle out like this. And now we're going to, let me just kind of move him down here for a second. We're going to form a right angle here, so I'm going to have a perpendicular line through this segment at that point, right? And then I'll just pull this guy up here to meet that perpendicular line. I'm eyeballing it, so actually this is not going to be beautiful, because it is not necessarily on that line. Now if we form this, well, let's just measure this angle here. Here we go. If I go, what is the measure of angle P, Q, oh, what should it be? 30 degrees. And it is exactly 30 degrees, because my opposite side over my hypotenuse is a ratio of 1/2. So now I know this triangle here and that triangle there are completely similar. All of the measures of the interior angles are identical, and the ratio of the sides is intact. And that is a pretty neat thing to think about.